This lesson is titled Solving Systems of Linear Equations. What we'll do is we'll understand what a system is, and then we'll learn how to solve systems of linear equation using both substitution and elimination. First, systems of linear equations. What we're trying to do is given two lines, we're determining the xy coordinate, or the point, where the two lines intersect. There are three possible cases here. The first is our two lines could intersect at one point. Okay, so this xy point would be the solution. So this is a case of one solution. The next case is of no solution. If we have parallel lines or lines with the same slope, they never intersect, so there would be no solution. The next case is if we have the same line, which is called collinear, or one line right on top of the other, and this is a case where there would be infinitely many solutions. Okay, in this class we're just going to deal with the first type, one solution, but this knowledge might be helpful for you for your next math class. Okay, so example 1, solve a system of equations using substitution. So we have two lines, x equals 3y minus 11 and 5x plus 4y equals negative 17. You could get these in the form of y equals mx plus b, graph it, and possibly determine the point where these two lines intersect. In this case, we're going to use substitution, and here's why. Our first line is solved for the variable x. What we can do is, since x is 3y minus 11, we can take that and substitute it in for the x in the second equation. So here's what that looks like. We have 5 times 3y minus 11. Note that this was x, but x is 3y minus 11, plus 4y equals negative 17. So in order to solve, we distribute the 5. And we're left with 15y minus 55 plus 4y equals negative 17. I'm going to combine a couple of things in the next step. These are equations that we've been solving. So 15y and 4y is 19y. And I'm also going to add 55 to both sides, which would be 38. Okay, and now we solve for y, divide by 19. And this gives us y equals 2. Now remember, our solution should be an ordered pair, or the x-coordinate and the y-coordinate of where these two lines intersect. So once you find one value, in this case we found that y is equal to 2, you need to find the next value. Okay, so you can substitute y into either equation, the top or the bottom, or the first or the second. I'm going to plug it into the first because it's going to be a lot easier to solve for x. So we have x is equal to 3 times y, which we just found to be 2, minus 11. So now we have x is equal to 6 minus 11. Oops, I almost gave it away. So x is equal to negative 5. So your answer, y is 2, x is negative 5. Or if we were in class, or perhaps for your next math class, you may also see this solution as an ordered pair. Solving a system of linear equations using substitution once again. So in this case, both lines, y equals 9x plus 13 and y equals 2x plus 48, they're both solved for y. So we're substituting y in for y. So these become equal to one another. Okay, so then we subtract 2x from both sides, and I'm also going to subtract 13 from both sides to get 7x is equal to 35. And we solve for x, so we get x is equal to 5. And again, you can plug in x equals 5 into the first or the second equation. Either one is totally fine. You should get the same result either way. Okay, and so we'd have y is equal to 9 times 5 plus 13. So y is equal to 45 plus 13. So y equals 58. Or as an ordered pair, x comma y, 5, 58. So that's the point where these two lines intersect. Next, solving a system of linear equations using elimination. So the goal with elimination is what we're going to do is we're going to add these two equations together, and we want one of our variables to cancel out or to be eliminated. So for instance, and I'm going to do this in a different color. Let's say we had negative 5x plus 3y equals 17 and 5x plus 2y equals 5, whatever. If we add these together, the negative 5x and the 5x will cancel out, and I would only be dealing with one variable in my linear equation. And so that's the goal. So you can choose to eliminate x or y. It's your decision. Pick the one that's easier. I also recommend making sure one value is positive and one value is negative so that when you add them together, they cancel out. This may be a little bit different than the way the online homework shows you. Okay, so in this case, I have two options. For the x's, I can both get them to 18x, or for the y's, I can both get them to 40. I'm going to choose to eliminate x because I think it'll be a little bit easier. Okay, so for this first equation, 6x plus 5y equals 11, I want to get the 6x to 18, which means I need to multiply it by 3. Okay, and when you're doing that, you have to multiply everything by 3. Because of that equal sign, what you do to one side, you have to do to the other. In the second equation, I'm going to multiply it by negative 2 because I want that to be negative 18x. One's positive 18x, one's negative 18x. When I add them together, they'll eliminate. Okay. So our first equation becomes 18x plus 15y equal to 33. And our second equation becomes negative 18x minus 16y equal to negative 40. So now what we do is we add our two equations together. Positive 18x and negative 18x cancel out. 15y minus 16y becomes negative 1y, and 33 minus 40 becomes negative 7. And so to solve for y, we divide by negative 1, and we get y is equal to 7. Now you can plug y equals 7 into the top or the bottom original equation. It doesn't matter which one. I'm going to plug it in. Smaller numbers are in the first equation, so I will use 6x plus 5y equals 11. So we have 6x plus 5. We just found, that y is equal to 7, and this is equal to 11. And so now we solve for x. We have 6x plus 35 equals negative 11. We subtract 35 from both sides. And we have 6x is equal to negative 46. Oops, I added a negative. Let's go back. That should be positive 11. Okay. Oops. Draw. So now we have 6x is equal to negative 24. And we divide both by 6 to get x is equal to negative 4. So we have x is negative 4 and y equals positive 7. Thank you for watching. If you have any questions, please feel free to reach out to me.